Most teams argue about the wrong thing when they pick a scraping framework. They line up Crawlee against Scrapy, read a dozen feature tables, and try to decide which one is objectively better. But that is not the real question, and the honest answer is a little deflating. The framework you should use is usually the one written in the language your team already speaks. Today, I want to walk through how Crawlee and Scrapy actually differ in 2026, where each one is genuinely stronger, and why the language your engineers already know decides this more often than any row on the comparison chart. I run scrapers for a living, the kind that pull public data at scale every day, and I have shipped production jobs on both of these, so this is a tested comparison, not a spec sheet read out loud. I am going to be honest about the trade-offs because both of these are good and neither one makes you undetectable. There is a Python option that has been proven in production for more than a decade, and a Node option that is younger but built for the browser-heavy web we actually scrape now. The skill is knowing which one fits your team and your targets before you commit a line of code. Some conditions, what these two actually are. Start with what each one really is, because the names get thrown around loosely. Scrapy is a Python crawling framework, asynchronous at its core, that has been the default answer for scraping in Python since long before most of today's targets existed. Crawlee is a newer framework from the team behind Epify, written in Node and TypeScript, that unifies plain HTTP crawling and full browser crawling behind one interface. Both give you the same core promise, a structured way to fetch pages, follow links, parse fields, and store the result, with the plumbing already built so you are not wiring retries and queues from scratch every time. The factor that really decides it, here is the thing I wish someone had told me earlier. The biggest deciding factor is not the feature list, it is the language your team already lives in. If your engineers write Python all day, Scrapy drops into a stack they already understand and the data tooling around it feels native. If your team is a Node shop or your whole product is TypeScript, Crawlee lets your scrapers share types, libraries, and habits with the rest of your code. Fighting your team's native language to chase a slightly nicer feature is a tax you pay every single day, and it almost never earns back what it costs. Scrapy and the value of age. Look harder at Scrapy first because its biggest asset is age. It has been in production for well over a decade, which means almost every problem you will hit has already been hit by someone else and written up somewhere. The ecosystem around it is deep, with middlewares, extensions, and integrations for nearly anything you need, plus item pipelines that give you a clean place to validate and store what you pull. That maturity is not glamorous, but at 3 in the morning when a job breaks, a well-worn path with 1,000 answers already posted is worth more than any shiny feature. Crawlee and the browser-first web. Now Crawlee, whose biggest asset is almost the opposite, it was designed for the web as it is today. The modern web leans hard on JavaScript, and Crawlee treats browser crawling as a first-class citizen rather than an add-on. It wraps Playwright and Puppeteer directly, so moving a crawler from cheap HTTP fetching to a full browser is close to a configuration change instead of a rewrite. It also carries a unified request queue and storage layer out of the box. If a big share of your targets need a real browser to render their content, that native browser handling is a genuine head start. The browser story on Scrapy's side, Scrapy can absolutely drive a browser too, but it is a bolt-on rather than a native limb. You reach for the Scrapy Playwright integration, wire it in, and it works well, yet you can feel the seam because Scrapy was built around raw HTTP requests first, so the split is honest. If most of your work is HTTP fetching with the occasional rendered page, Scrapy plus its Playwright plugin is clean and fast. If browser rendering is the main event across most of your targets, Crawlee handling it natively will feel smoother and cost you far less glue code to keep alive. The blocking helpers, honestly, both frameworks ship helpers meant to reduce how often you get blocked, and I want to be careful and honest here. Crawlee includes tools that rotate through realistic browser fingerprints and manage sessions so your requests look less uniform. Scrapy has its own rotation middlewares and a large library of community plugins that do similar work. These helpers genuinely reduce clumsy mistakes, the obvious tells that get a lazy scraper flagged in seconds. But let me be clear, None of this makes you undetectable, and I am not here to teach evasions. They lower the noise floor a little. They do not turn the wall off. So come a known from concurrency. The concurrency models are worth understanding because they shape how each one scales. Scrapy runs on Twisted, an event-driven networking engine, and its whole design fires many HTTP requests at once without blocking, so a single process can push a high volume of raw fetches efficiently. Crawlee rides Node's event loop, which is also asynchronous by nature, and layers an auto-scaling pool on top that grows and shrinks the number of concurrent tasks based on how much CPU and memory are actually free. Both are built for real concurrency, and neither one makes you reason about raw threads, which is a genuine mercy at scale. Auto-scaling in practice. That auto-scaling piece is one of Crawlee's nicer touches in practice. Instead of you guessing a fixed concurrency number and hoping it is right, it watches system load and adjusts the number of parallel requests on the fly, backing off when the machine is stressed and pushing harder when there is room to spare. Scrapy gives you an auto-throttle extension that does something similar, adapting the delay based on response times, though it leans more toward politeness to the target than toward squeezing your own hardware. Both help you avoid hand-tuning a magic number. They just optimize from slightly different starting philosophies. The learning curve. The learning curve splits along familiar lines. Scrapy has a steeper first climb because it has its own structure. The spiders, the settings, the pipelines, and you have to learn that architecture before you are productive. Crawlee tends to feel more approachable to a JavaScript developer because it reads like ordinary async node code, closer to writing a normal script than adopting a whole framework's worldview. But do not read easy as better. The gentler curve helps only if your team is already fluent in Node. Drop a Python team into Crawlee, and that advantage evaporates fast. Whipland's unpimping advantage evaporates fast. Deep-hyping advantage. One real edge on the Crawlee side is TypeScript. Because it is written in TypeScript, you get real type checking across your scraper, which catches a whole class of silly mistakes before you ever run the job. A mistyped field, a wrong shape passed between two steps on a big long-running scraping codebase, that safety genuinely adds up. Scrapy is Python, so you get Python's flexibility and its optional type hints, which are useful but not enforced the same way by default. If strict typing across a large team is something you care about, that is a fair point in Crawlee's column, and worth weighing. Proxies matter more than the framework. Proxy handling matters more than the framework choice on hard targets, and both give you a clean place to plug it in. Each one lets you route requests through a rotating pool and swap the address per request, and neither one ships the addresses themselves. That part is on you. This is the layer I run myself, real mobile proxies on real carrier SIM cards, because for the strict targets, the address you arrive on decides more than any framework feature. Cheap data center IP ranges will fail on a tough site in Crawlee, exactly like they fail in Scrapy. The framework routes the request. It does not launder where it came from. The request queue and storage. Both frameworks handle the boring but critical end of the pipe, the request queue and the storage. Scrapy has its scheduler and item pipelines, a mature path for deduplicating requests and writing clean records as they arrive. Crawlee ships a request queue and dataset storage that work locally out of the box and scale up onto Apify's platform if you want that. Either way, you get a structured place to track what you have fetched and land what you parsed, so you are not reinventing a queue and a writer for every new job. That saved plumbing is most of the reason you reach for a framework at all. Community is the support you never signed. Weigh the community because it is the support contract you never actually signed. Scrapy's is enormous and old, so almost any error message you paste into a search has been answered, and there are middlewares for edge cases you have not even hit yet. Crawlee's community is smaller but active and growing fast, with solid documentation and a company behind it that ships updates regularly. For a truly obscure problem, Scrapy's decade of accumulated answers still wins. For a modern browser-heavy problem, Crawlee's docs often speak more directly to what you are actually trying to do. How I actually choose. So here is the decision I run every time. I start with the team because it dominates everything else. A Python team scraping mostly static or HTTP reachable data. I point at Scrapy without a second thought. a Node or TypeScript team, or a project where most targets are JavaScript heavy and need a real browser, I lean Crawlee for the native browser handling and the typing. Only when the team is genuinely comfortable in both languages do the finer features get a real vote, and even then I weigh maintenance and hiring over any single capability. The best framework is the one your team can keep alive for a year. I run this infrastructure in production myself. Real crawlers pulling public data at scale on both of these frameworks, so this is the ladder I actually climb, not a preference. If you want the full versions, the written guides with real setups, the proxy configs, and the honest trade-offs between these two, along with the picks I actually use, they are at dataresearchtools.com, with working code and no undetectable promises. The point was never which framework is cooler. It is which one your team can run well and still keep running when you are asleep. The honest limits, let me be straight about the boundary, because neither framework moves it. Picking Crawlee or Scrapy does not make anything undetectable, and it does not change what you are allowed to collect. The same rules apply either way. Public data, a robots file respected, an official AP or bulk feed preferred where one exists, and a polite rate held so the site never gets a reason to shut the door. The framework decides how comfortably you build and maintain the scraper. It does not decide whether what you are doing is welcome, and no helper in either toolbox turns that judgment off for you. So to recap, Crawlee and Scrapy are both strong, and the choice is driven first by your team's language, Python for Scrapy, Node and TypeScript for Crawlee. Scrapy wins on maturity, ecosystem depth, and the mountain of answers behind it. Crawlee wins on native browser handling, auto-scaling, and real typing for the JavaScript-heavy web. Both ship helpers that reduce clumsy blocking, and neither one makes you undetectable. Run the honest test, match the tool to your team and your targets, and pick the one you can keep alive. Subscribe for a new scraping infrastructure breakdown, and I'll see you in the next one.